Hi guys, in this video we're going to talk about two center theorems involving Euclidean geometry. We're focusing on the circle geometry this time around. Okay, remember guys, this section of work hinges a lot on prior knowledge involving triangles. So all your knowledge about triangles, interior angles, exterior angles, congruency, similarity will be put to the test in this section. And also all your knowledge involving lines and line geometry will also be tested, parallel lines. Okay, so make sure that knowledge area is intact before you start embarking on this journey of Euclidean geometry. If you do that, it will be much easier. So the theorem we're going to first talk about is the one that talks about a line drawn from the center of a circle. In this case, we have a center O, and we're drawing a line from the center to reach chord AB. Now, if this line is a perpendicular line or is perpendicular to the chord, then this line is going to bisect the chord. Okay, so any line drawn from the center of a circle and is perpendicular to a chord will bisect that chord. So the next thing we want to do now is to prove this theorem by just making a construction and then using the knowledge that we've spoken about, the triangles, the lines, and see if we can prove that. So the first thing we need to do is just to make a construction, drawing from the center O to A, from the center O to B like that, such that we form two right-angled triangles. And basically what I just need to prove here is to prove that these two triangles are congruent. Once I can prove that these two triangles are congruent, then I might as well prove that AD is equal to DB and that the line OD is actually a bisector to the line AB. So I'm going to use congruency to do this theorem. Okay, in triangle ADO and triangle BDO, angle ADO is equal to angle BDO, which is 90 degrees. It's given. We already told the line is perpendicular to the chord. OA equals OB. The red eye, they're equal. OD is a common side to these two triangles. Okay, so remember, when you're proving congruency, you need three pieces of information. Then I can clearly see that triangle ADO is congruent to triangle BDO, and the reason is right angle, hypotenuse, side. Therefore AD is now equal to DB. The second theorem that we're going to prove is about the angle at the center being twice that at the circumference. Okay, suppose we have a circle with center O, and we're going to have an arc AB, and we're going to use this arc to construct an angle at the center, and the same arc will construct an angle at the circumference. So we've used this arc to form angle AOB. Okay, and then we're looking at the obtuse angle here, not the reflex. We're going to use the same arc to form another angle ACB like that. So the theorem says an angle that is subtended at the center by an arc is twice the angle that is subtended at the circumference by the same arc. Okay, how are we going to prove this theorem? Again guys, whenever you're proving your geometry theorems, you're going to have to practice the routine drawing of these constructions, drawing in the lines, draw in a certain construction. It's a routine procedure. The only way you can get to the bottom of this is by practicing and practicing. Okay, so we're going to draw in a construction line that goes in from C through the center like that, and let angle C be divided into two angles, C1 and C2, and the same instance, angle AOB is now divided into O1 plus O2. And basically with this theorem, you're trying to form two triangles and then use the idea that because these triangles are being constructed using a center, they're going to be equal sides, isosceles triangles, because there are two equal sides, and that's how you just construct your knowledge, your proof. So OA equals C because they are radii. Angle A is now equal to angle C. These are angles opposite equal sides. Then angle O1, exterior angle of triangle OAC, is now equal to A plus C. This means that O1 is equal to 2 of C1. In the same instance, I can similarly prove that O2 is equal to 2 of C2. Okay. Now, angle O2 plus angle O1 is now equal to angle 2C1 plus 2C2. Therefore, we have proven that angle AOB is equal to 2ACB. It's time for some practice, guys. Don't disappear yet. Just stick around for some practice questions. The first question we're going to look at, we're given a diagram of a circle with center O. We are told that OC, the ratio OC is to CD is equal 3:2. And we also told that AB is equal to 48 centimeters. So if AB equals 48 centimeters, calculate the radius of the circle. So at this juncture, guys, you might want to pause the video and give yourself a chance to attempt this question. Obviously, you can see there are two right angles involved with this line drawn from the center theorem. So usually you're going to be applying the theorem of Pythagoras. Okay, so take time, work it out, and then press play again. Okay, so the first thing we can pick out is that AC is equal to CB. Why? Because OA is perpendicular to AB. So rather, OC is perpendicular to AB. So OC is a perpendicular bisector of the line AB, of the chord AB. So AC is equal to CB, it's 24 centimeters. Now, we're given this ratio 3:2. The common mistake is to take these values as to mean that the length of OC is 3 centimeters, the length of CD is 2 centimeters. That's not what it means. Remember, guys, ratio means proportion. So it means OC is actually 3 parts, CD is actually 2 parts. So if we take the entire length of the line, that is OC plus CD, we should get 5 parts. That's where this 5x is coming from. So the entire length of the line is actually 5 parts. And when you divide it into those 5 parts, you get 3 parts is OC, 2 parts is actually CD. So we can say OC is the same as 3 of x, and CD will be the same as what? 2 of x. Okay? Now, OD and OB should be equal because they're radii, all coming from the center of the circle to the circumference of the circle. It should be the same distance. So it should be 5x. So OB is the same as OD. So it's 5x. So whenever you're dealing with this type of questions where they ask you to calculate and they give you information of the center of the circle, there's a line drawn from the center. Usually you have to come up with a right angle triangle. Try to come up with the size of this right angle triangle in terms of x. Okay? Once you can see the sides of the right angle triangle in terms of x, apply the theorem of Pythagoras. So in triangle OCB, we can see that OB is the hypotenuse of this right angle triangle. So OB squared must be equal to CB squared plus OC squared. OB squared is 5x squared, CB is 24, and we're going to square it, and then OC is 3x, we're also going to square that. Gives us 25x squared is equal to 576 plus 9x squared. Move the 9x squared or subtract 9x squared from both sides. You remain with 16x squared is equal to 576. If we divide both sides by 16, we get x squared is equal to 36. From here now we take the square root of both sides. X is 6 centimeters. But we want the radius of the circle. So the radius is going to be 5 times 6, which is 30 centimeters. Again, this type of questions, there is a familiar pattern. Try to determine the length of the sides of the right angle triangle that you form. Okay, form two right angle triangles, determine the sides in terms of x, and then use the theorem of Pythagoras to solve the problem and find out what the value of x is. Okay. In this question, we're told O is the center of circle ABCD. DC is equal to CB. Angle D1 is equal to 40 degrees. Determine with reasons angle B1, angle O1, and angle D2. So again, pause the video, give yourself a chance to practice these skills. Practice makes perfect. The more you practice with geometry riders, the easier they become. Okay, shall we begin? So normally the approach I adopt when dealing with this kind of problems is to quickly put the information on the diagram as I get it. So there is O, the center of circle ABCD. They're telling me DC is equal to CB. So I can already see that this triangle here is going to be isosceles. Okay, where the equal angles, these two angles are going to be equal. By just looking at the information, DC is equal to CB. And then they're telling me that B1 here is 40 degrees. I can already see that B1 is also 40 degrees. Okay. All right. So we want to find the size of the magnitude of angle B1. Okay. So we're going to say DC is equal to BC. That's given. Then we're going to say now B1 is now equal to D1, 40 degrees. These angles opposite equal sides. Okay, so the angles opposite equal sides. So B1 is also 40 degrees. We've given the reason. Let's calculate O1. O1 is an angle that is at the center, okay, that is subtended by this chord DC or this arc DC. We have said that the angle at the center is always twice the angle at the circumference. Okay, so we can clearly see that if B1 is 40 degrees and is subtended by arc DC, the same arc subtends angle O1. So angle O1 is going to be equal to 80 degrees. And the reason, angle at center twice that of circumference. Okay, so it's angle at center. Sometimes you can just write angle at a center, it's fine. So O1 is 80 degrees. Okay, how about angle D2? How am I going to determine the size of angle D2? Well, what if I could work out this whole angle D1 and D2? I already know that this is 40 degrees, so if I know the size of the entire angle, I can subtract 40 degrees. I'll know what D2 is. How am I going to do that? So normally when you have a center O given and there are triangles involved that are being drawn from the center, with the sides from the center, usually you get isosceles triangles there. If you look at it, OD is equal to OC. So which means the base angles that are going to be formed in those two triangles are also going to be equal. Okay, so we already know that O1 is 80 degrees, so which means C1 and then D1 and D2, when we add them together, they will give us, plus 8 will give us 180 degrees. So if we make C1 x, D1 plus D2 x, we can find out what x is easily. Okay, so 80 degrees plus 2x is equal to 180 degrees. Angles in triangle, right? And therefore we can easily solve this. Subtract 80 from both sides, we get 2x equals 100 degrees, x equals 50 degrees. So angle C1 is 50 degrees, D1 plus D2 is also 50 degrees. Okay, so now I can simply say D1 plus D2 is equal to 50 degrees. We already know D1 is 40 degrees, so D2 must be what? 10 degrees. Okay guys, that's how you can apply the geometry, the knowledge areas that we've spoken about to solve these geometry riders. There is no really easy way to go about this, except that you need to develop some momentum, develop some routine practicing, and with routine practicing it becomes a little bit easier. Okay, in the next video we're going to talk about the other two theorems that we need to learn to prove, and we also do some practice questions. Thanks for watching guys. I hope you enjoyed this video. Geometry riders can be exciting. Remember always to go for the background knowledge, your triangles and your line geometry as well. It will make this section much easier. I'll see you guys around next time. Thanks for watching.